Good evening, my dear friends, my dear students. This time I am back once again, myself Dr. Manasi. Today we will be discussing on galvanic cell and electrochemical series. Now, what does a cell means? A cell actually is a device which converts chemical energy to electrical energy. A cell is a device which converts chemical energy into electrical energy. The other name of the galvanic cell is called the voltaic cell. To be more precise, we can say that cell is a device which converts chemical energy to electrical energy or vice versa. Today what we will be discussing is galvanic cell or the voltaic cell which converts chemical energy to electrical energy. Now first let us understand the structure of a galvanic cell. It comprises of two different chambers consisting of two different metals dipped into their individual solution, the concentration of the solution being aqueous 1 mole. Now we will be discussing about that particular galvanic cell which uses zinc and copper as electrodes. We can see from the structure that zinc rod is dipped into its own solution, that is zinc sulfate, the concentration of the solution being aqueous 1 molar, and in the right hand side copper rod is dipped into copper sulfate solution, the concentration of the copper sulfate solution being aqueous 1 molar. And these two are connected by the terminals of a battery with a wire fitted with a device called galvanometer. Now galvanometer is a device which has a pointer and which by deflecting its pointer shows the direction of current flow. Now when we talk about galvanic cell, we have to remember the thumb rule of the working principle of the galvanic cell. That is, we have to remember the word LOAN, L-O-A-N. L stands for left, O stands for oxidation, A stands for anode, and N signifies negative. That means the metal which is in the left hand side will be assigned as anode, and in anode there will be oxidation. O stands for oxidation, and this anode will be assigned negative. Obviously in the right hand side there will be reduction. It will be assigned cathode with a positive sign. Now what happens, since we have in the left hand side zinc metal, and it will undergo oxidation, only one reaction can happen, and that is zinc will be releasing electron converted to Zn2+. That means from 0 its oxidation number will increase to +2 and it will be releasing electron, which signifies that it is undergoing oxidation. On the other hand, copper will be accepting these released electrons from zinc, and its oxidation state will decrease from +2 to 0. It signifies that as the oxidation number decreases and it accepts electron, it signifies that copper necessarily undergoes reduction. Now what is the half cell reaction? If we consider these two separate chambers in the left hand side and in the right hand side are called half cells, and together they are called the complete galvanic cell. Now if we consider the half cell reactions, what we find is Zn releasing 2 electron getting converted to Zn2+ aqueous 1 molar, and copper 2+ accepting these 2 electrons is transferred to or transformed to copper solid. These are the two half cell reactions, and combining or clubbing these two half cell reactions, what we get is the complete cell reaction, that is Zn plus copper sulfate getting converted to Zn sulfate plus copper. Copper sulfate signifies that copper is having in its oxidation number +2, from where it is getting converted to metallic copper, that is oxidation number 0. From +2 its oxidation number is reducing to 0, and Zn means metallic zinc, which is having an oxidation number of 0, is converted to ZnSO4. That means Zn2+ plus SO4 2-. That means it releases 2 electron and its oxidation number increases from 0 to +2. So we can see it is well explained that zinc is undergoing oxidation and copper is undergoing reduction, and at the same time some amount of heat is also evolved. Now if we consider this galvanic cell, what it is supposed to do, with the aid of this chemical change, that is zinc getting converted to Zn2 plus and copper 2 plus getting converted to copper, there is a release of electron, and naturally this electron flows from zinc chamber to copper chamber, and obviously the current should flow in the opposite direction, as we all know. But this may be the ideal case, but this is not actually happening. The moment we connect these two metallic rods or metallic electrodes with the terminals of a battery, the first moment it will start working, the current will flow momentarily, and immediately at the next moment the flow of current will stop. This is the practical scenario. But why it happens so? Why it is so? It is supposed to ideally flow electricity in the opposite direction to which the electron is flowing, but it is not doing the same. Why? There are some reasons. The reason being, Zn continuously is getting converted to Zn2 plus, releasing 2 electrons. So surrounding Zn electrode, zinc metallic rod, there will be a number of Zn2 plus ions. And in surrounding the copper electrode, there will be number of electrons. These Zn2 plus ions surrounding zinc electrode will be repelling each other and will not allow further Zn to get converted to Zn2 plus, releasing electron. That means the release of electron will stop after some time, after some moment, after a few moments, and naturally as the release of electron and the flow of electron will be stopped, current flowing will also be stopped. This is the actual scenario. Now how to resolve this problem? How to resolve this problem? The solution of the problem is to insert a device in between these two chambers called salt bridge. What is a salt bridge? A salt bridge is nothing but an inverted U-tube, the two ends of which are dipped into, one end being in zinc sulfate solution and the other end being in copper sulfate solution. Moreover, this salt bridge contains KCl or KNO3 or NaNO3 like inert materials. I'm saying that these are inert materials, but actually they are inert